All right, so let's get through this. This will show up a little bit on the test that will now be on Friday. But I would say that it's not going to show up as much as the other two topics that we've already covered. Okay, let's try again what I just said 15 seconds ago. This will show up on the test on Thursday, but I would venture to say that it will not show up as much as the other two topics that we have covered, which are
Martina, number 7.
twice.
Maybe 3 times, 4 times, maybe 5 times.
You know how many questions are
Should be around 25.
What are the other two topics that we've covered? Polynomials and radicals. Oh. So what we learned today really falls kind of under the radicals category because we're going to deal with properties of exponents. But one of the things that we learned is that every single exponent, or let me rephrase, certain types of exponents can be rewritten as radicals and vice versa. And that's the first rule I'm going to give you today right off the bat, the first property. And you look at this and you're like, but I don't get it because like math is not supposed to be letters and there's only letters up there. Because this is general. You've already seen this. This is showing up on your notes already when you learn about radicals. The x is a base, the a is an exponent, and what did we call where the b is?
Index.
Yeah, the index. What's the index that you're most used to?
2.
A 2. So what we learned today is that every single radical can be rewritten as a rational exponent. What is the root in the word rational? Ratio. What's a ratio? Yeah, as she said, it's a fraction. But we want to be more specific than that. Okay, what associations do we want to make in that fraction? The denominator is what used to be the index, and the numerator is the exponent that was on top of the base. You will need to know how to go both ways. You will need to know how to take a radical and change it to a rational exponent. You will have to know how to take a rational exponent and change it back to a radical. Where would you pull cross multiply out? Just like that word. You just saw a bunch of arrows, so you just saw cross multiply. Yeah.
Is there ever going to be no exponent? Like if there's no exponent?
There's always going to be an exponent. If you don't see an exponent in algebra, what exponent's there? 1. Now, one thing that I should point out to you, because some resources point this out better than others. If your directions say just to simplify, like let's say you weren't told anything beyond just simplify, between the two, that's the form you'd want to stay in. Okay? There are 3 types of exponents that you should never leave if you are trying to simplify an expression. When an expression is in simplest form, there's 3 types of exponents you should never see. So if you're actually listening right now, one of them should be taken care of. Like I'm about to ask you for the 3. One of them you should already know. It's on the board right now. If you are in simplest form, what type of exponent should you not see? There's only one type of exponent on the board right now. Do we know what an exponent is?
Yes.
A.
What is one type of exponent that you should never leave if you're going to have an expression in simplest form? A fraction. Very good. You cannot leave a fraction up in a power. So what would you do in that case? You would switch it back to a radical. There's two other types of exponents you should never leave, and we'll get to that later in the slide. Anybody want to guess what the other two are? Because these actually you should know. These should be reviewed. No, not so much a decimal. Yeah, you shouldn't leave a decimal, but like the reason for not leaving a decimal would be the same thing as a fraction. Because every decimal could be rewritten as a fraction, so it's like a part of a number. It falls under the same reason, but there's two other types of numbers. No, but at least that's a good guess. Right, you're just like shouting things out just to shout them. Nobody wants to take like an educated guess what types of numbers? Because these should actually be reviewed. That's one of them. Very good. A negative. A negative, yeah, negative. That's two with one more. You're just shouting things out. You're like, oh, here's I learned a new shiny word. And you just shout it out.
Zero.
Okay, so the first one in red, that was kind of like maybe the main focus of the lesson, and that's the new one. Really, everything that you're about to see in blue should be reviewed. Some things reviewed from this class, some things reviewed from previous years. This first one we've done in this class. What does this tell you in words? If I am multiplying and I have the same base, what am I allowed to do with the powers? You can add the powers. Lorna, did you sign out when you left to go to the restroom? You need to do that. Just sign it out for a few minutes and then sign it. If you are dividing the same bases, this we sprinkled in a little bit, not as much as the multiplying one, but we have sprinkled in a little bit, and I'm hoping you've seen it before. If you divide the same base, what do you have to do with the powers?
Subtract.
Subtract the powers. You had like one or two like that on the assignment that was due. This should be reviewed. Okay, this one we haven't done so far this year, but I'm hoping you've seen it before. If I have some base being taken to a power, and that term is being taken to another power, what can you do when you have a power of a power? What can you do with those powers? Yeah, Cody, multiply. Thank you. Multiply. I would hope you've seen that before. Okay, this one we worked on a little bit last week. We sprinkled it in. This next property tells you when you have the power of a product. Inside the parentheses, I am multiplying. If I am multiplying, what am I allowed to do with that power?
Distribute.
Very good. I was actually surprised. Last period, somebody also got that one right away. I thought that one might take forever for you guys to answer, but yes.
We're too smart.
When you're multiplying inside of a parentheses, you can distribute a power on the outside to each number that you multiply. Conversely, this one we probably had more experience with last week. We did this one quite a bit with all the division that we did. If you are dividing inside of a parentheses, normally shown as a fraction, and you have a power on the outside, if you're taking that entire fraction to a power, what are you allowed to do with that power?
Distribute.
Also distribute. You can give that power to each term. Okay. This one we haven't done yet this year, but I had asked. This is one of the questions I had asked you. What this property tells you: if I have some base being taken to a negative power, you cannot leave it like that. And the more common mistake is that people think that it makes the base negative. Maybe we don't think too well abstractly using unknown numbers like variables. But for instance, if I were to tell you, oh, what's 5 to the negative 2? I have historically tons of people that say, oh, yeah, that's negative 25. No, it's not.
Because of negative times the negative.
Well, no. Yes, but not for your reason, because I'm not multiplying a negative times a negative. What's my base here? Oh yeah, I have a positive 5. I cannot multiply a positive number times itself any amount of times and never get a negative, even if that exponent is negative. So what you can do with a negative exponent is change the location of it, what's known as a reciprocal. If you don't see a fraction, it's because it's considered to be a numerator. Like this could be 5 to the negative 2 over 1. It's on top. If this 5 to the negative 2 was on the bottom, like wherever it's located in fraction form, change the location. So if I want to make this 2 negative, I would drop it as if it was hot, and then I could make it positive. What is 5 to the negative 2? It's the same thing as saying 1 over 5 to the positive 2. Now what's 5 to the positive 2?
25.
25, so it's 1 over 25. The other one we talked about earlier today, you should never leave anything to a 0 power. So if you didn't know already, this tells you what is any number to a 0 power.
1.
It's 1. Doesn't matter if the number is negative, doesn't matter if the number is a fraction or a decimal, any number to a 0 power is a 1. Some of you might see it like canceled out. When it cancels out, it's 1. Where's that 1 coming from? It's the coefficient. When you don't see a number in front, what number's there? 1. A 1. Any questions there? Is that the last one? Alright, so let's do some examples. We'll have maybe this one and one more lesson where I have to use this program, and then I hope to never have to use it again. So, convert to radical form. Assume that all you can see right now is this, which is a rational exponent. We led off the lecture saying that, Cassie, any rational exponent can be rewritten as a radical. What you would want to make sure first is that rational exponent is the simplest form. Can 3 over 7 be simplified? No. So then what do you gather from this example that you saw on the first slide? The denominator becomes the index. The numerator stays with the base. So this is the same thing as saying 7th root of x to the 3rd. Hey, Tad. You know this already? Any questions with that one? Really, overall, I mean, you'll have a chance to work on this on Wednesday in class, but like the assignment for this week from Khan Academy, I think is actually pretty thorough. Like, it has a little bit of everything, and if you understand that, you should do well. The bad thing is that this is not going to be featured a lot on the test. The polynomials and radicals are going to be featured more, but if you can understand the stuff on Khan, you should at least get those questions right on Friday. Alright, so this one is not going to tell you to go backwards. Let's convert to exponential. Every radical can be rewritten as a base to a power and vice versa. So here we're starting with the radical, and then we want to go to exponential. So Cassie, This is just one step. What would this look like in exponential form? True? You want to help True out?
Wait, the numerator will be 5,
Mm-hmm.
and then the A, that would be like this one, right?
I like where you started. I like the whole numerator.
But I don't know the denominator.
Right. You told me that the index would become the denominator, but Mr. Romero, I do not see an index. There you go.
Maybe 2.
It would be 2. And where'd you get that 2 from? I don't see a 2 anywhere. Yeah, if you can't see it, it's because it's a square root, and the index for a square root is 2. Normally, you won't see problems asking you to leave an exponential form, because exponential form is not considered to be simplest form, but just in case you do, I mean, if you are explicitly told, hey, leave an exponential form, then yeah, you got to do what you're told. The last thing would be just to make sure that the fraction is the simplest form, which it is. I can't do anything with a 5 over 2. Right, Julius? Okay. Dane, how's this one a little bit different? Okay, you just see a parentheses, and then what else? Very good. That's exactly very good. Oh, wait, but this is different because now the exponent's on the outside. Well, this next step here, you don't really have to show. This is more giving you the rationale as to why I end up with why I end up with. But like what we're gonna get to is that it makes no difference. That's the grand story here, is that it makes no difference. But here's why it makes no difference. If we focus first just inside of the parentheses, what's the index?
5.
Okay. I cannot see an exponent on top of the b. So what number is really there?
1.
Is a 1. And then one of the properties that we learned on the first page said that if you have a power of a power, what are you allowed to do?
Distribute.
Not distribute. What can you do? Multiply. Well, distribute implies that you're multiplying more than once. Here I'm only multiplying once. So what can we gather from this? Well, I want you to see first, what is every fifth root the same as? It's the same as a 1/5 power. Then yeah, besides that, I don't expect you to show that step. Really, all I would expect you to know is, hey, variable on the outside, same thing happens as before when it was on the inside, and you just end up with the 3/5 power. But this shows you why. You're thirsty for knowledge. Okay. See, now pay attention. See what the directions say. They say to simplify. When you're just told to simplify, really you should be trying at all costs to get rid of this rational power. Now, in this case, look, what else is different here? Look, we don't have a variable. We have a constant. So that brings Mr. Calculator into play. Now, remember that you're not going to have a calculator on the test, but you're also not going to have, really, you're not going to have any that would need a calculator. Let's put it that way. You'd be more likely to get a variable than you would be to get a constant. So my first question to you would be, well, what is a 1/3 power the same as? If we're trying to get rid of that rational exponent, what can I convert a 1/3 power to get rid of it? What? Sorry, you lost me. Square root. I was thinking about uniforms. Huh? Not a square root, no.
Cube root.
Say it again?
Cube root.
Cube root, yeah. And even if you didn't know that name, cube root, you would have said, hey, Mr. Romero, the 3 is in the denominator. So that becomes the index. The 1 stays with the 216. Yes, Claire?
would it be wrong if we kept the one?
I wouldn't hold it against you, but just doesn't need to be there. Now, when you get here each day, I ask you to take out all your materials. What are some of the things included in that list of materials that you should have had?
Work.
Well, yeah, the pencil, paper, stuff, but a calculator as well. So, just do me the favor, if you have a calculator and you just don't have it out yet, bring it out now. Because this is gonna help get you by at least 2 of the exercises that's due on Friday now. You won't use the calculator on the test, but you're not gonna have any like this on the test. But at least I want to show you how to use the calculator so you can get through the assignment. Because if you know how to use the calculator, it'll get you drills in about a minute. You're being asked to take a cube root. We could do this with a tree the same way we did with a square root. But instead of having pairs to get out, you would need now triples in order to get out. But 216 is a perfect cube. Meaning the same way with a perfect square, you can do it either in your head or with a calculator. You can do the same thing here. So I want to make sure you know how to use it. Every some scientific calculators have a dedicated cube root key. Every 4 function calculators have square root buttons. So every calculator has a square root, but right now we're not using a square root. If you hit the square root, you're going to get it wrong. If you have a cube root button, you might have to hit like a math menu. It depends on the manufacturer. So I might have to ask you that you hit a button that says math and then this pops up. If you cannot find a cube root button, every scientific calculator should at least have a generic root button. Where now the only thing is that before you hit that root button, you would have to tell it that you want a cube root. You have to hit the 3 before. So that's what I want to do. Make sure that you know how to find it. If not, that's where I'm here to help. I'll save the day. But if you do it, like, can anybody tell me what's the cube root of 216? If you're doing it properly, what should you be getting?
6.
It is 6. So if you're not getting 6, let me know now. Speak now or forever hold your peace. This is a little exercise.
Oh, I can divide it.
Me and my calculator. Getting to know your calculator. Let's see, hit an exponent. Here's your root button. Second. I'll take it here. 3. Second. There. You don't have a cube root, so you have 3. Second. And then the root button. And then 2. Anybody else having trouble finding it? No. You got it, Lorna?
Yeah.
Anybody else? You gotta hit second and then the root button. You gotta hit that one. No. Second. 3. Second. If you can figure out how to use it, second. You gotta put the 3 first and then second. And then that one is. Well, that's not for you guys. You didn't bring the sticker?
Oh,
No,
I thought we
you
had to
guys-
sign up.
No, that's only for my
Okay.
guided study. You use the sticker. Where's your sticker? Did you scan it?
Okay.
I know you can talk to me like that.
Ryan, stop flirting. Alright, here's another one. Tad, you're gonna want to write this one down. This one might end up being your favorite.
I can't see.
It says 7 to the 1/2 times 7 to the 1/2. You actually have a couple of options here because more than one property of exponents applies. Okay? Because I have the same base, it doesn't happen very often, but because I have the same base, what am I allowed to do with the powers if I wanted to? One of the properties on the first page. If you have the same base, what are you allowed to do with the powers? Add them. What's 1/2 plus 1/2? 1. And I would end up with 7 to the first power, which is just 7. Hip hop hooray. Okay? But because I want to try to stress to you this importance of getting rid of the rational exponents, and also I want to stress to you how to get rid of rational exponents, what is a 1/2 power the same as? If I take a number to the 1/2 power, what is that the same as? If I can rewrite them as a radical, what radical is the same thing as a 1/2 power?
Divided by 2.
What radical? So you're going to tell me some type of a root. What type of a radical is the same as a 1/2 power? The denominator becomes the index, so the index will be 2. What type of a radical has an index of 2? Suna? Square root. It's the same thing as saying square root of 7 times square root of 7. And it isn't that one way is better than the other. It's just, seldomly are you going to have the same base. So this is more consistent, I would say. And then last week we learned what happens if you multiply a square root times itself.
It's itself.
Just the number on the inside of the 7. Very good.
I've learned so much over the class, Mr. Roman.
Thanks, man. Okay, so here you go. Case in point. My bases are not the same. And actually, I could teach you a way to make the bases the same, but that's pretty math intensive. You have to have a very good sense of numbers to know how to make the bases the same. And even then, it doesn't always work. You can't always make bases the same. But what I would try to get you to focus on here is the fact that the denominators are the same. And if the denominators are the same, what else is going to be the same? Thank you, the indexes. So when I write these in radical form, I have a fourth root of both of those numbers. One is a 5, one's a 125. We learned last week with multiplication, Deja, that as long as the indexes are the same, you're allowed to multiply inside with inside. So 5 times 125 is 625. But you're like, whoa, Mr. Romero, that's too big. Well, you could do a tree if you wanted to. But then the other, well, it's not a perfect square, but this is perfect to the fourth. So like, part of today's lesson is trying to get you to use your calculator. If here you will no, I have never seen a scientific calculator that has a fourth root button. So you're not gonna have a button that just says fourth root, but you do have your root button. So find your root button, just put a 4 in before. And tell me what's the fourth root of 625? It should be 5. If you can't get 5, say something now. Dane, you got a 5? And Claire got it also? And you got to chuckle about it because like, hey, we got the same number on our calculator. Right. You got a 5? Me too. That is neat. All right, one more then before we go. The base here is negative 32. I want to take it to the 4/5 power. Because the base is a constant, it's not a variable. Yes, you could get your calculator to do this for you now, but the whole purpose of today is to try to avoid the calculator until at least at the very end. So if I want to get rid of that rational exponent, where's the 5 going to go?
Index.
The index, the 4 is going to go on the inside with a negative 32. If I take a negative number to an even power, what do I get? What type of number do I get when I take a negative to an even power? If I get a negative number and multiply it times itself an even amount of times,
You get a positive.
you are going to get a positive. A positive what? Whoa, that's super huge. Yes, I would agree. If your calculator wouldn't do this for you, you'd be in trouble. Well, you wouldn't be in trouble. You just have to go back up here and do a tree. You might not be able to do a tree with 1,048,576, but can you do a tree with 32?
Yes.
And this 4 would just mean that you would need to put 4 of those trees. Like for instance, when you do a tree with 32, you get 5 twos. So this would just tell you have to have 4 of those. So 5 twos, 5 twos, 5 twos, 5 twos. How many twos would there be?
20.
Yeah, there would be. But anyways, just put this into your calculator before we leave, and just double check. Make sure you should get 16. Make sure you know how to do a 5th root.